In today's video, I'm going to Dockerize the MERN application we built last video. This will allow me to run the entire app locally with a single command. So I can just run docker compose up, and that's going to spin up all of our containers. And in Docker Desktop here, you could see we have our database container, the API container, the front-end dev server, and our Caddy container. I'm using Caddy as a reverse proxy, which allows me to run the app with a custom domain and SSL certificate locally. Once these are all running, we could go back to the browser and see that the app is running on HTTPS and then our auth.localhost domain. So this works just as before. And if I open up the network tab and navigate to the settings page, you'll see that our API is running on api.auth.localhost, and it's also secure. You'll be surprised how easy it is to get all this set up. And if you don't know anything about Docker, this will be a great place to learn. I'll be going over Docker volumes, networks, port mapping, and more. I also want to mention that this video is strictly for setting up the development environment with Docker. In the next video, I'll show you how to optimize this setup and get it ready for production, because the Docker files and configuration will be slightly different for production. So stay tuned for that. With all that out of the way, let's get started. Before we dive into the code, I want to go over some notes on Docker. So Docker is just a platform for developing, shipping, and running applications in containers. A container is just a lightweight standalone package that includes everything you need to run a piece of software. This includes your source code, your runtime, dependencies, environment variables, and any configuration files. Containers are also encapsulated and isolated from each other and the host system, but they can also talk to each other. Here's a diagram of what that kind of looks like. So you have your host machine, which could be your laptop or a VPS, and on that host, you have different containers running. So you could have a container for your API and one for your database, and then maybe an Nginx container. And each container has its own source code and all of its dependencies encapsulated in the container. And it's running separately from the database container or the Nginx container. We can wire up these containers on the same networks, and we can also add volume so that certain files on the container will actually map to files on the host machine. And you can also map ports. So a port on your host machine will map to a port on your container. So you'll see all of that in action in a little bit, but here's just a brief overview. Lastly, I want to talk about the Docker file and Docker images. So a Docker file is just a set of instructions for building an image. These instructions can include installing dependencies, copying source code, setting configuration, and anything else that your app needs to run on that container. Docker uses the Docker file to build an output image, and then a container is just a running instance of an image. So when you want to push a new feature or a new version of your app, you'll have to rebuild the image because the original image would only have the source code and dependencies of the previous build. But once you add more code onto it, you need to rebuild the image so that the source code can be updated on the container. With all that in mind, let's go and build our first image. I'll have the GitHub repo linked in the description below, but it's the same one from last video. If you want to reference any of the code that I'll be writing in this video, just make sure to check out the yt-docker branch. So this branch will have all the code for this video, and the other branches are linked to different videos. Now let's begin by creating our Docker file. So here I'm just picking up where we left off in the last video, and in the backend folder, let's create a new file, and we'll call it Docker file, and make sure it's spelled exactly like that. In here, we need to define all of the steps that it takes to run our app on a container. The first step is specifying a base image. So each container can have a pre-built configuration suited for your application needs. So since we're using Node to run our API, we want to use the Node base image. So we can specify that image by saying from Node, and then we need to pass it a tag. So I'm going to use node 18, because we're on version 18 of Node. And then I'm going to add this bookworm slim tag. I won't go into depth on why I chose this specifically, but I'll leave a link in the description below where you can read about which Node base images you can use. Another common one you'll see is Node 18 Alpine, and you can use that if you like. So after we've specified the base image, we want to set our working directory to /app. So once we're in the container, we just want to run all of our commands from the /app directory, and that's just convention. Now we need to install dependencies. So if we were just running our API locally without Docker, the steps for running it would be opening the package.json and basically running npm install to install all of our dependencies. And once those are installed, then we can run npm run dev, and that'll start up our server. So that's essentially all we need to do inside the container. However, our container doesn't know about the dependencies that our app requires because right now it's just empty. It has no files in it. So let's copy over our package.json and the package lock file so that we can install the dependencies. We can do that by calling copy, and then we'll do package star.json. And this is just going to copy the package.json and the package lock.json. And then we want to copy it to the current working directory, which again is /app. Once we have the package.json, we can install the dependencies. So we'll say run npm ci, which is a clean install. And it's basically just going to install the exact versions that are specified in the package.json and in the lock file. After installing the dependencies, we want to copy all of our source code. So right below, we'll do copy, and then we want to specify the path in our current working directory. So that's this backend folder. That's where our Docker file is. So we want to copy everything in our current directory to the current directory on the container. Once we have all of our source code, we can start up the server. To do that, we need to run a command. So we'll specify the command directive, and then we'll pass an array of arguments. And we want to run npm run dev, because this is the script that we specified in our package.json right here, and that's going to run the TS node dev server. So that should be enough to get our container up and running. There are a few ways to run Docker containers. One way is if we just have one container for our app, then we could go in the terminal and just do docker build and then specify the directory of the Docker file. In this case, it's in our current directory. And this will go read this file and build an image based on these instructions. After the image is built, we could run docker run and then specify the name of the image, and that will spin up the container. However, in our application, we're going to have multiple containers. We have one for our API, one for the front-end dev server, one for the database, and also the Caddy web server. And I don't want to have to go into each directory 4 times and run docker build and then docker run. So when you have an app that needs multiple containers, you want to use a tool called Docker Compose. And that just allows you to spin up multiple containers and wire them up together on a network, and also add other features like volumes or port mappings and things like that. So to use Docker Compose, we need to define a Docker Compose file. And I'm going to go to the root directory of our project and create a file called docker-compose, and it's going to be a YAML file. In here, we'll specify a name for our application, and I'll just call it MERN app. And then we need to specify all of our services. Our services would be all of the containers that we want to run in our app. So under services, let's indent a line, and we'll define all of the containers we need. So first we want our API, and under the API, we need to specify the build property. And underneath that, we want to give it a context. And our context is going to be basically where the Docker file is relative to the compose file. So that would be in the backend directory. And then we also need to pass a Dockerfile property, and we'll just call it Dockerfile since that's what we named it here. If you had a Dockerfile.dev, then you would need to put that here like that. After the build property, I want to add a restart property, and that's going to be set to unless stopped. So this is basically going to restart our container unless we manually stopped it, which will ensure that the container will restart. Next, let's specify the env file. And this is just going to tell the container where the environment file is for that container. We want to go in the backend folder and then the .env. So that'll just use this file in here. And lastly, let's define our port mapping. So we'll add a ports property, and then we want to define the host port and the container port. So we'll change this to 4004 because our API runs on port 4004. This first port here refers to our host port, so basically localhost 4004 on my laptop, and the second port is the port on the container itself. So now that we have this defined, we should be able to start up our service. In the terminal, let's go back out a directory so that we're at the root directory here, and that's at the same level of the Docker compose file. And then we can just run docker compose up, and by default, it's going to know to look for a Docker compose file in the current directory. And then it's going to run our Docker file that we've defined here and hopefully spin up our container. So let's give that a try. And you'll see that we got a default network created and our container here, MERN app API 1. And if I go to my Docker desktop, I'll see it running here. Here's that API container, and in the logs, you see that the server is running on port 4004. Now you also see this big error connecting to the database, and that's because we don't have a container running for our database. And in our index file, we try to connect to the database here, and if that throws an error, we exit the process. So let's also add a log here saying connecting to the database. And for now, let's just comment out the connection here. So since I changed the source code here, our container should restart, but you could see that it's not. And the reason for that is once we've built the container, it's encapsulated. So it has all of our source code and dependencies all baked into the image, and then the image is just running on the container. So when we make changes to our source code here, that's not getting reflected on the container because the container is already running that image that was built when we ran Docker compose up. So let me just stop this process right now. We could do Control-C. Now the way to get around this is using Docker volumes. So anytime I make a change to my source code, I don't want to have to stop the server and then run Docker compose up and spin up the entire stack again. Because to get any changes that we made, we'd have to rebuild the container and go through this Docker file again. And that would be pretty excessive to have to do that every time we make a change. So here's where volumes come in. We can set up a volume on our host machine, which would be my laptop here, and I can basically tell the container that everything in this backend directory, all of my TypeScript files that I'm editing, should map over to a directory on the container running here without having to rebuild the container. So to do that, let's go back to the Docker compose file, and right above the ports, let's specify the volumes. And in here, we first want to specify the path on our host machine. So from here, we want to map the backend directory to the /app directory on the container. And with this line, basically this backend directory will act like a symlink to the /app directory on the container. Below this, we also want to add another line, and we want to do /app/node modules. We don't want to specify a host path. So this line is basically just going to say, ignore the node modules on our host machine and just always use whatever's on the container. So these node modules will never be updated on the container. I also forgot to add a Docker ignore file. So let's go ahead and add that. We want to call it .dockerignore. It's one word. And in here, we want to specify all the files on our host system that should not get copied over to the Docker container. When we run this copy command, we don't want to copy the node modules, we don't want to copy the dist folder, and we don't want to copy the .env file. We also probably don't want to copy the postman JSON or some of the other files. So to prevent them from getting copied, we can just add them to the Docker ignore. So we'll say node modules and dist. We don't want to copy any env files, and we also don't want the postman.json because that's not relevant for our app when it's running. So now let's give this a save, and we'll also save the compose file. And now we need to rebuild our container and run the app. So we can run docker compose up and then pass the build flag to rebuild the container. Without this flag, it's just going to run the already built container and just spin it up. So it's not going to have any of our changes. Now let's make sure to rebuild. Now we see our server is spun up on port 4004. Now I should be able to hit that in the browser. So we'll go to HTTP localhost port 4004. And we see our status check here. So our container is running and it looks like we're able to access it over localhost. And if I modify my source code, like add a few exclamations, you should see that the server restarts. And when I go to the browser, we'll see that change reflected. And we don't have to rebuild the container. If it doesn't auto reload for you, you might need to go into the package.json and add a --poll flag. I was reading that sometimes you need this flag to get all of that working in a Docker container. So with this command, it should auto reload all of your TypeScript files. I'll get rid of that. And now we can set up our database container so that we can connect here without crashing. Let's stop our server here. Then we'll go back to the Docker compose file. And above our API, let's define our database container. We'll call it Mongo. And for our image, we're going to use the Mongo image, but then we want to add a tag so that we could specify a version. We're going to use Mongo version 7.0.12. Below that, let's define our port mapping. So we're going to map the localhost port 27017 to the container port. And below that, we want to add our volumes. And this time, instead of adding a bind mount, which would be a path on our host machine that'll map to the container directory, I'm going to use a named volume. So named volumes are managed by Docker, and they don't require me to specify or map a directory on my host machine. I just let Docker manage it, and it'll persist anytime my container restarts or shuts down, which is super helpful because when we stop our container, we don't want to lose any of the data in our database. So I'm basically just going to let Docker manage that volume. So to do that, I can just say Mongo_data, and it's going to map to the /data/db on the container. And this is just the path on the container that the Mongo data is stored at. So we just want to make sure to map this volume on this container path. Since I'm using a named volume like this, I need to define it within my Docker compose file. So down at the bottom, I can specify volumes, and in here, I'll create Mongo_data. And so this is just going to tell Docker to automatically create and manage this volume called Mongo data. And now I can reference this volume within any of the services. Next, let's add a network. So we can specify networks, and then I'll give it a name of MERN app. And then we'll set the driver to bridge. You can read about the different options on the docs, but we don't really have to worry about this for now. Then let's attach our API and the Mongo container to the network. Underneath the volumes, let's just specify networks, and then we'll just say MERN app because that's what we called it down here. Then we'll copy this over for our API container as well. So now both of these services are on the same network. Now to explain what a network does, I built a little diagram here. So this is the setup without a Docker network. So you have your host machine and you have all the containers that are running individually. In order for one of the containers, like our API, to talk to the database, it has to do that through the host ports. So the database is going to map localhost port 27017. It's going to map to the container port 27017. And when my API tries to connect to the database, instead of connecting directly to the container on the network, it's going to connect to HTTP localhost 27017, and that's going to get mapped over to the container port. And so you're always having to connect to the other containers over the host ports, which is not ideal. And it'd be better to just reference the container by name or by some ID, and it'll take care of the communication and the linking between the containers. So with a Docker network, here's kind of a different picture. So we can assign all of the containers to a specific network, and then the containers can just talk to each other directly without having to worry about exposing ports and mapping host ports to container ports. And this is especially useful when we implement Caddy, because we're only going to expose 2 ports here, port 80 and 443, and then all requests will come in through that host port, and then Caddy will be our reverse proxy, and it's going to forward the request to either the API or the front end, and it can just reference these containers by the service name. So I can just do something like API on port 4004, because that's what I defined as this service. And that just allows the containers to communicate a lot easier, and we don't have to worry about any port mapping. So that's just a brief diagram, and hopefully that made sense. Now I need to update my env file to reference this Mongo service on the Docker network. So let's open up our .env, and you could see previously for the Mongo URI, we were connecting over localhost. But we can change this to Mongo, because that's what we've defined in our Docker Compose service here. And so that's how we can reference it. And now, technically, since they're on the same network, we don't actually need this port mapping because we're not connecting on localhost port 27017. We can get rid of this and it'll work. However, when you're running in the development environment and you want to use something like MongoDB Compass, you're usually going to connect through localhost like this. And since this Compass app is running on my host machine, I can't reference it through the Docker network like this. This won't work because I don't have access to the Docker network through here. And so usually in development, I'll just keep that port mapping just so I can connect through a graphical user interface. So I'll uncomment that, but in production, you would not want to do this because you don't want to expose your host port, which would be your VPS, out to the world. You only want to run your database on a private Docker network. So this is fine because we're running it in development. So now that we've updated this file and changed our environment variables, we should be able to restart our containers and the API should connect to the database. So we can run Docker Compose up and we'll pass the build flag. And let's watch these logs as it rebuilds our container. We should see our database start up. And I just realized that we need to add the dependency to our API. So we don't want to start our API container until our database is ready, because our API tries to connect when it boots up. And if this container is not running yet, it's going to crash. So I need to tell Docker to wait for this service to finish building. And once this container is running, then move on to this service. So I can do that by going to the bottom and just saying depends on, and then we'll specify the Mongo service. So let's give that a save and retry. And now we should be able to see connecting to the database. And now let's just double check that everything still works. So our API is running and it looks like we're connected to the database. Now, if I open up the Compass app, I should be able to also connect over localhost. And here's our database. And I have a previous user. So it looks like both of our containers are running successfully. And now we just need to spin up our front-end container, which is going to run our dev server. The Docker file for our front end is going to look nearly identical to our API. So let's just copy the Docker file and the Docker ignore, and we'll paste those into our front end directory. In the Docker ignore, we don't need this postman, and we could just leave these other files. Then in the Docker file here, we want to run all of this code where we copy our package.json, install the dependencies, then copy our source code. But then we also want to add some extra flags here. And this is just to get the Vite dev server to run in a Docker container with hot module reload. So we just need to pass these flags to the dev command. Now we can go back to the Docker compose file, and below the API service, let's add our front end service. So we'll call this front end, and we need to pass the build parameter. Then we'll give it a context, and that's going to be the front end directory. And the Docker file will also just be Docker file. Then we'll set the restart to unless stopped. And also the env file will be in the front end directory. Next, let's specify the volumes. So we want to map the front end folder to the app directory on the container. And then also just make sure we don't override the node modules. Then we'll attach the network, and that's just MERN app. And for the port mapping, we're going to use 5173 because that's the default that the Vite dev server uses. Then lastly, we want to make sure that we only start the front end when the API server spins up. So we'll say depends on API. And this is going to create a sort of chain. So the front end container depends on the API. And when we go to the API, that depends on the database. So Docker Compose is smart enough to know that it first needs to run this service, then the API, and then lastly the front end. So let's give this a save, and we'll close out of our server here, and then run Docker Compose up with the build flag, and that should build our front end container. And it looks like we're getting some errors here. So let's close this out for now. So that's happening because Docker does not like this command that we're running here. And we can actually just get rid of it from the Docker file and add the command in our compose file. So on the front end, below the ports, we can just specify a command property, and that'll be equal to npm run dev, and then we'll pass these same flags. You also need to update your Vite config file for it to work properly in Docker. So you need to add a server property, and inside that, you want to set host to true. And this will just get the whole Vite dev server working inside of Docker properly. So now if we give this a save and rebuild our containers, that should spin up all of them. And let's check here. So it looks like they're all running. And now if I go to localhost on port 5173, we should see our front end load up. And let's just try to sign in with our test user. And that seemed to go through. So here you see our API is running on localhost 4000 and our app is working just as it did before. Now all anyone needs to do when they want to run our app is run Docker Compose up, and it'll spin up all of our services and get them up and running super fast. Now let's test the hot reload server. So I'll just change this my account, and let me search for that. I'll add a few exclamation points, and you see our server restarts, and in our browser, we see that change. So it looks like it's working. Now we're ready to add a custom domain for our site and get it running on HTTPS locally. We're going to use Caddy as our web server because it automatically obtains and renews TLS certificates for us with no extra configuration. And it's also really easy to set up a reverse proxy with just a few lines of code. So to get started, let's go back to our compose file, and we need to add another service. So below our front end, we'll call the service Caddy, and then we need to specify the image. So in our case, we're going to use the Caddy image, and the tag will be version 2-Alpine, and this is a pre-built image for Caddy. Now let's define our ports. So I'm going to map port 80 and port 443 on my host machine to the same ports on the container. Port 80 is the default port for HTTP, and 443 is for HTTPS. Next, we need to add some volumes. First, we'll create one for our Caddy data, and this is going to be a named volume, so we'll let Docker manage it, and it's going to map to the /data directory on the container. And then let's also create a volume for Caddy config. So we'll say caddy_config, and that's going to map to the config directory. So these are just the directories that Caddy uses by default to store necessary data and configuration. And we're just adding these volumes so that that data persists when the container stops and starts. Since we specified these named volumes, we need to make sure to add them down here in our volumes. Next, let's add it to our network. So we'll just specify the networks property and assign it to the MERN app network. And then we'll say that it depends on our front end and also our API. Now, the last thing we need to do is add our Caddy configuration file. So right now we just have our image and there's nothing telling our Caddy web server what it should do when it receives a request. We can tell our Caddy web server what to do through a configuration file called a Caddy file. Let's create that Caddy file. So at the root directory, we'll create a new folder called Caddy. And in here, I'll create a Caddy file. First, let's add some global options. We could do that by opening up curly braces, and I'm just going to specify local certs. If you look at the docs, the local certs option just causes all certificates to be issued internally by default. So Caddy will self-sign SSL certificates using the local Caddy certificate authority. Then all we have to do is add that root CA certificate to our trust store, and our browser will trust all those self-signed certificates. So after we pass this option, we need to give it a domain. So in my case, I'm going to do auth.localhost. Then we'll open up curly braces. And here we need to add a directive. So I'm going to say reverse proxy. And then I need to specify where I want to proxy the request. And since this container is on the same network, I can just reference the front-end container or the front-end service and specify the port. So that's all we need to do to get the proxy set up. And I'm also going to add the encode option and set that to gzip. And that's just going to give us some compression. Although you don't really need this when you're running locally, but I'll keep it for now. Now we need to add our reverse proxy for the API. And I'm going to run that on api.auth.localhost. And we need to specify the reverse proxy. And that's going to forward to our API service on port 4004. So that's all we need to do to get the proxy set up. And this is just one way of doing it, where I run the front end on one domain and the API on a subdomain. If you want to run both on just one domain, then there's an example on the docs. If you look up reverse proxy, here are a few other ways to do it. So you can just specify one domain and add a reverse proxy directive that checks if the path starts with /API and then anything after that, then forward it to localhost 5000. Then below this, you could add another reverse proxy that'll just forward to your front-end container port. I didn't want to do it this way, so I didn't have to deal with this /API prefix, but it's definitely a valid option if you just want to keep it under one domain. For now, I'll just keep it on api.auth.localhost. The next step is to add these host names to our local host file on the computer. Because if I put this in my browser, it's not going to know that it should resolve to 127.0.0.1. To tell my browser that it should resolve to that IP, I need to modify the host file. So I'm going to open up my terminal, and on Mac, the host file is under /etc/hosts, and I'm going to need to enter the password in. And in here, we need to add 2 lines. So I actually have this here from when I built this previously, but right below that, I also need to add the API. So first we need to add the IP that we want the host to resolve to, and that's this local host. And then we need to add the host name. So I'm just going to add api.auth.localhost, and that looks good. To save this, we can do Control-O to write it out, and then Tab to complete, then Enter, and Control-X to exit. So once you've updated that host file and added the host names, your browser should resolve these domain names to localhost. The reason I chose auth.localhost as my test domain is because .localhost is a reserved TLD. There's an article that I'll link in the description, and it talks about these reserved top-level domains, and there's 4 of them. There's test, example, invalid, and localhost. So these 4 TLDs will never be valid TLDs that you could use on the internet. They're strictly reserved for testing and documentation. So when you're running locally, you wouldn't want to make your domain auth.com because that could be a real domain that's out there on the internet. And you wouldn't want your browser to resolve auth.com to localhost. So you can technically use any one of these TLDs and you don't have to run it on auth. I just picked this as a placeholder name. Now that we have this file, we need to actually use it in our container. So let's go back to the Docker Compose file, and under volumes, I'm going to add another volume, and this time it's going to be a bind mount. So I'm going to map this local Caddy file to this path on the Docker container. And this is going to be under the Caddy folder, so just make sure to add that in there. And now we should be good to start our server. And before we do that, I realized that this Caddy service is actually under the front end service. So I had an extra tab here. So just make sure that it's at the same level as the services property. Then make sure to shift all of these over. So that looks good. Now we can also get rid of all of our port mappings for the API and front end. So these ports here, I'll just remove that. And then also on the API, we don't need that port mapping. And that's because we're using Caddy as our reverse proxy to forward those requests to the containers on our network. So now that we have this Caddy server set up, it's going to handle all traffic coming in on port 80 and 443 on the host machine. It's then going to take that traffic and route it to either the API container or the front end. And since these are all on the same network, they can communicate easily. And I don't need to reference the host port 4004 because I can just reference the container directly. So I hope that makes sense, but you could see in the Caddy file, I'm just referencing that container on the same Docker network. Now let's give this a save and run Docker Compose up with the build flag. And now we should be able to visit our app on auth.localhost. So we see a warning here saying your connection is not private. And that's because our browser doesn't trust the self-signed certificate that Caddy generated. So if you click on this box here, you'll see certificate is not valid. And if you go to the details, you'll see that it was issued by the Caddy local authority and it's for this domain. So our browser, Chrome, obviously does not trust a certificate that was signed by the Caddy local authority because this isn't an actual valid certificate authority. To get around this, we can tell our browser to trust all the certificates that the Caddy local authority generates. To do that, we have to update our trust store, and usually Caddy will do that by default, but since we're running it inside of Docker, it doesn't have access to our host trust store. So we have to do a little bit of extra configuration since we're running it with Docker. First, let's go to the Caddy container running on our machine, and we're going to inspect the file system. So you can just click Files here, and under the data directory, there's Caddy, PKI, authorities, local, and then this root cert. So this is the root certificate for the local certificate authority, and we just want to save this file to our desktop. Once you have that, you want to open up your trust store, and I'm on Mac, so for me that's the Keychain app, and then go to System and Certificates. And this is going to have all of the certificates that you trust on this computer. From here, you can go to File and then Import Items. Then go to the desktop and we'll just import that certificate that we just downloaded. You'll need to enter your password. And that should get added to your trust store. However, it still says that it's not trusted. So if you double click into it and then open up this trust field, then you want to set this to always trust. So that looks like it worked. And now our computer trusts this, and you see that this expires in 2034. So we won't have to worry about doing this again. Let's close out of that. And if we refresh our browser, then you could see our app is running on HTTPS, and we have our custom domain working. And now let's just try to sign in with our test user. And we see invalid email or password. Let me just make sure that we're hitting the API correctly. And it looks like we're still using the old API URL. So we need to actually update our env file. That would be in our front-end directory and also our backend one. So this app origin should now be our auth.localhost. And then let's update the frontend.env file. This will be api.auth.localhost. So let's see if that reloaded the container. And it looks like we have to actually rebuild it because it's still using the old environment file. So let's close out of this and then run docker compose up. Now we'll try it again. So that looks like it worked. And here in the network, we could see it's secure and we're hitting api.auth.localhost. Now that everything's running on HTTPS, we can actually go back to our front-end code and go to our cookie options. And in here, we no longer need this check for the node environment because we can set secure to true because we have everything running over HTTPS even locally. So now let's give this a save and we should verify that everything still works. I could clear sessions. And if I delete my access token, it should generate a new one. So I'm just going to refresh here and go to cookies. I'll delete the access token and then go to the settings page. And we see that our token was refreshed and then we fetch the sessions. So it looks like all of our cookie logic is still working with this domain change and the Caddy reverse proxy. So that's all it really takes to get your app up and running locally with Docker. Now you wouldn't want to deploy this setup to a production server because our API is running the TypeScript node dev server, our front end is running the Vite dev server, and our Caddy container isn't issuing real SSL certificates and it doesn't handle a real domain. To get our app ready for production, we'll need to add multi-stage builds to our Docker files and also make some modifications to our Docker compose file. I'll show you how to do all of that in the next video, so stay tuned for that if you're interested. That's it for this video. Thank you guys so much for watching. Leave a like if you enjoyed and subscribe if you haven't already. It would help me out a ton. Let me know in the comments if you have any feedback or what you guys want to see next, and I'll see you in the next one.